Hello friends, welcome to my channel VK Voice. Today we are going to discuss chapter number 2, Work, Power and Energy. This is the fifth part of this chapter. In the fourth part, we have discussed about the relation between the kinetic energy and the momentum. And the relation was K, kinetic energy, is equal to P square upon 2m and P is equal to under the root 2mk. Now, what sorts of questions comes in the examination based upon this formula? Questions comes like this. You are given two bodies. One is heavier and other is lighter. Find the ratio of kinetic energy of these bodies if their momentums are same. Then how you will solve this question? You can solve this question very easily. Just take two bodies. Suppose body A and body B. A and B. Body A is a heavier body and body B is a lighter body. Mass of A is m, momentum is Pa, and mass of B is small m, momentum is Pb. Since momentum of the both bodies are given similar, therefore you can put equal to sign over here. That means Pa is equal to Pb. Now apply this formula over here. So you will be having Ka, that means kinetic energy of A, heavier body, is Pa square upon 2 capital M. Similarly, kinetic energy of lighter body is Pb square upon 2 small m. If I will divide these two like this, Ka upon Kb, I will be getting small m upon capital M. And you know small m is the mass of lighter body, capital M is the mass of the heavier body. So capital M is greater than small m, which means the ratio of Ka and Kb is less than 1. Hence Ka is less than Kb, or you can say the kinetic energy of heavier body is less than kinetic energy of lighter body. So this is there, and in this way you can find the ratio as well. If the masses of the two bodies are known to you, you can easily calculate the ratio of the kinetic energy. Sometimes the question is asked like this, one atom of hydrogen is given and other atom of helium is given, which one is having, if the momentum is same, both of the atom has the same momentum, which one will have the more kinetic energy and what will be the ratio of this type of question can be asked in the examination. Similarly, the question can be asked on the momentum as well. What is the ratio of the momentum if the energy of the two atoms are similar? One is a heavier atom and other is lighter atom. That can also be calculated by using this relation. So now we will calculate that also. Two bodies are given to you, A and B. We are to calculate the momentum ratio of momentum of A and B. We are to calculate. Again, suppose M is the capital M is the mass of A and small m is the mass of B, and suppose Ka is the kinetic energy of A and Kb is the kinetic energy of B. Now if I substitute the value, Pa, momentum of A, will be under the root 2mka, and similarly Pb is equal to under the root 2mkb. Again, if I substitute the values, I will be getting Pa upon Pb is equal to under the root m upon m. Now as you know, m is greater than small m, therefore Pa is greater than Pb. That means momentum of heavier body will be more as compared to momentum of lighter body. And what will be the ratio? That can be calculated with the help of masses. If the masses are known to you, you can easily calculate the ratio of momentum of the two bodies. In this way you can solve these two questions very easily. Keep it in your mind. These are very important questions which are usually asked in the examination. Now we will discuss work energy theorem. What is work energy theorem? In the previous section we have discussed about energy, and I told you if work is done on the body, In that case, what happens? The energy of the body increases. And if work is done by the body, in that case, what happens? The energy of the body decreases. So, whenever there is work, there is a change of energy. This statement is nothing but work energy theorem, according to which increase in kinetic energy is equal to the work done, or change of energy is equal to work done. So today we are going to discuss this only. So how you can verify it? So verification is very easy. For that, you just take a body. Suppose you are having a body of mass m. This is the body whose mass is m and it is moving with a velocity u, and you apply a force on it, due to which its velocity changes from u to v and it covers a distance s. So how much work is done over here? So let us see what is the work done. You know, work done is equal to force into displacement. Now force, as I told you, force applied is F. So I will put F into S over here. Now calculate the value of S. How you can calculate? By using the equation of motion. And the equation of motion, as you know, is V square minus U square is equal to 2AS. From here I can calculate the value of displacement S. So S is equal to V square minus U square upon 2A. And if I substitute this value over here, the value of S over here, then I will get work done is equal to F into V square minus U square upon 2A. And also you know F is equal to MA, mass into acceleration. So I will substitute the value of F over here. I will be getting work done is equal to MA into V square minus U square upon 2A. So 1 A and A cancel. You will be getting work done is equal to 1 by 2 mv square minus 1 by 2 mu square. Here, as you can see, this is the final kinetic energy of the body. This is the initial kinetic energy of the body. So you can write work done is equal to kinetic energy final minus kinetic energy initial, or you can write the work done is increase in energy. Work done is equal to increase in energy. So this is nothing but the proof of work energy theorem. So next topic which we are going to discuss today is the difference between kinetic energy and potential energy. What is the difference between kinetic energy and potential energy? Now, difference between kinetic energy and potential energy. First difference is the definition itself. You know, potential energy is the energy due to position, size or shape, while kinetic energy is the energy possessed by the body due to its motion. So one difference is there. And second difference is potential energy is the amount of work done to bring the body to its present state, while kinetic energy is the amount of work done by the body before it comes to rest. Second is potential energy can only change to the kinetic energy, while the kinetic energy can change to various form of energy. So these are the difference between kinetic energy and the potential energy. Three differences I have discussed with you. These are the difference. One more thing, keep it in your mind, and that is, what is degraded energy? Whenever there is a change of energy, one form of energy get changed into another form, then some part of that energy get changes into that type of energy which is not desirable. That not desirable energy is lost. So that energy which is lost during the process of conversion of energy from one form to another form is known as degraded energy. Now next thing which we are going to discuss is law of conservation of energy. Law of conservation of energy, as you know, everybody knows, is energy can neither be created nor be destroyed. It only changes into one form to another form. Now what is the proof of that we are going to discuss. Now proof of law of conservation of energy, how you are going to prove it. For that, just take a body which is falling freely like this is falling freely, and take 3 points during its free fall. I have taken 3 points over here. You can see a body of mass m is over here, it is falling down, this is the ground. 3 points are A, B and C. So it is falling, and at point B it has just fallen through a distance x, and total height of this body from the ground is h as shown in the figure. Now first of all, I will just see what is the total amount of energy when the body was at point A. Now at point A, the body is not falling still, its velocity is 0. Since its velocity is 0, therefore its kinetic energy is also 0. And it is at a height of h, therefore its potential energy is mgh. So total energy is, as you know, kinetic energy plus potential energy. Kinetic energy is 0, potential energy is mgh. Therefore total energy at point A is mgh E1. That means the energy which is there at point A is mgh, point number 1. Now suppose the body comes to the point B, then what is its velocity over here? Suppose let the velocity is v1 at B when it has traveled through a distance x. Then I can apply the equation of motion, and you know equation of motion is v square u square plus 2gh. So you are having v1 square plus u, as it was 0 initially. So 2gx, x is the distance. So you are having v1 square is equal to 2gx. So again, if I just find the kinetic energy as you know 1 by 2 m v1 square. Now substituting the value of v1 square, which is 2gx, you will be getting 2 and 2 cancel, you will be getting kinetic energy is equal to mgx. Now what is the potential energy? The distance now is h minus x. At point B, the distance of the body from the ground is h minus x. Therefore potential energy is mgh minus x. So total energy will be the sum of these two, kinetic plus potential. Kinetic energy, as we have calculated over here, mgx, and potential energy is mgh minus x. When I will solve, I will get again mgh. So at point B also, the total energy of the body is mgh. Now finally the body comes to the point C, that is it fell on the ground. Then in that case, what is the final velocity when it strikes the ground? Again I will use the equation of motion, and the equation of motion, as you know, v square plus u square is equal to 2gh. That formula I am using. V square is equal to u square, initial velocity was 0, 2gh. So kinetic energy 1 by 2 m v square. Substituting the value of v square, 2gh, 2 and 2 cancel, I am getting mgh. And at ground height is 0, h is 0, therefore potential energy is also 0. So potential energy is 0, total energy will be kinetic energy plus potential energy. Kinetic energy is mgh and potential energy is 0, therefore it is mgh. Now if I see the three energies, energy at point A, energy at point B, energy at point C, equation number 1, 2 and 3, I will see that all the energies, that mean E1 is equal to E2 is equal to E3. 3. That means energy is not changing. Total energy of the body remains same at different point, which is nothing but law of conservation of energy, according to which energy can neither be created nor be destroyed, hence proved. So today, friends, we have discussed about the so many important concepts. We have discussed the relation between kinetic energy and the momentum, and the question based upon that concept. And then we discuss about the work energy theorem. We have discussed the differences between the kinetic energy and the potential energy. And most important concept which we have today discussed is the law of conservation of energy and its proof. I hope you have understood well these concepts, but if you have still some doubts, you can just make a comment in the comment section, and keep watching my channel VK Voice and subscribe it so that all the important information may reach to you during this lockdown period. My best wishes. Thank you very much.